Hi guys, let's talk a little bit. BJ requested to see some area perimeter volume questions. So there's actually two in this one. I'm gonna talk a little bit about area perimeter volume. Then I'm gonna skip down to the very last contextual problem because it's actually linked to this one pretty carefully. Um, area perimeter volume. So there's a link between the K factor and like the dimension of the thing you're looking at, and I'll try to explain the best I can. And I don't know if this will be the same thing I did on the key or not because well that was made several days before this video. But here's the deal. Let's just say you have this figure, and I'm going to keep it super simple. I'm going to make it a rectangle because rectangles are easy to calculate with. But this will apply to all planar shapes, like all two-dimensional shapes. So say I have this side length, let's call it A. Let's call this guy B. And then I have this K factor of X, meaning I'm going to blow this shape up, not with dynamite, but into a bigger shape, which I will now make it blue. Okay? So the thing to keep in mind is that using K factor in a similar fashion, using in similarity, basically means I'm going to take this side length, multiply by my K factor to get this side length. So this side would actually be A times X. If K was 2, it would be A times 2, B times whatever. So this one would be, of course, B times X. It's being a rectangle. This would be A times X, and this would be B times X. So right here, we can kind of start getting this notion that the K factor will be nothing more than just like the sides of the perimeter, the perimeter added together times X. And we can actually prove that pretty formally, um, quote unquote, prove. So like we have this perimeter of the red figure, the original figure, and this is going to be the sides added together. Okay? Now I'm going to write this below the text, so please follow this with me. So if I clean this up a little bit, I know this is going to be 2a plus 2b. So I combine like terms. AA is 2a, BB is 2b. Over here I can do the same kind of thing. So of course I'm going to call this P prime because that's my new perimeter, and prime indicates like the scaled perimeter. This is going to be a little bit different. This is going to be AX plus BX plus AX plus BX, right? And I just got that by adding the four sides together because hey, that's how you find perimeter. So if I do a little fancy algebra here, I mean I'm going to do some factoring. I can notice that there's an x in each term, so I can pull that out in front, leaving just a plus b plus a plus b, which of course a plus b plus a plus b is the same thing as 2a plus 2b. B. Right. So if I look and compare this perimeter to this parenthetical phrase, they're actually the same thing. So 2a, 2b is the same as 2a plus 2b. So p is the same as 2a plus 2b. So here's what I can do. It's not magic, but p prime should be the same thing as x, which is my k factor, times p, because p is my substitution. So what this tells me is that if I want, and I'll highlight as I talk, if I want my new perimeter, my scaled perimeter, I simply have to take the old perimeter that I had times my scale factor x, which is what we discovered before. Now, this in itself is not astounding, but it is, and I'll take this, I'm going to move it, actually, let's move it right here. This in itself isn't astounding, but it is when you think about how this applies now to, say, area. So same kind of setup, and again, we'll use simple shapes to kind of keep it going. Um, let's just use rectangle, right? Same setup. So this is A, this is B. Let's use K equals X. So if I'm looking at this new shape, this scaled shape, the side lengths, of course, would be A times K and B times K, right? So if I'm looking at the area, and please note this is area this time, of this shape should just be A times B because area is length times width. And of my new shape, the area, A prime, is going to be AK times BK, the side lengths multiplied together, AK times BK. Now let's leave the red side alone. Let's focus on this blue. I'm going to drop below the text. So if I do a little bit of common term grouping, oh, you know what? I'm sorry, I made an error up here. This should be X's, not K's. Oh, good lord. So this is B times X, A times X, because that's the K factor. That's an X and that's an X, right? So if I combine some terms here, X times X is actually X squared, A times B, and you guys probably guess what I'm about to do. I'm going to pull the same trick I pulled the last time around, where I notice that the area is equal to AB. That's also AB, so I can do a little switcheroo. So the area, my new area, is going to be my squared x factor times my old area A. And of course, in this case, if you kind of backtrack it, the area is going to be squared in this particular case because, well, x showed up twice in multiplication, one per side. I didn't multiply to get my perimeter, which is why I never had the square k factor, but I do have it here because I am multiplying side lengths, hence multiplying an x times an x. Which is why I can claim the area if I want my new area, a prime, again I'll underline here, I just take my old area times x squared, so you can probably guess, I'm not going to show it for volume, but my new volume is going to be my old volume times the cube factor of k, because for volume I'm multiplying three things together, length times width times height. So the reason this helps us, if we drop down all the way to the very bottom, if you read this question, I'm not going to read it for you, but please go ahead and pause if you need to read and catch up or look at your key or whatever you have to do. We can actually solve this problem really, really fast. So let's establish really quickly that we're looking at two similar triangles. I have a vertical angle here. These are told to be parallel in the story, so these have to be congruent as well. So I have similarity of two shapes, and I can notice right away the k factor is 3, getting bigger. So going from my original to my industrial zone is k equals 3, and I can see those by looking at a single side length of my known similar. So they're similar by AA. The k factor is 3. So if I know that the area of my original is 1.4, which is height, times 1.0, which is base, times 0.5, because that's the formula, 1/2 base times height, I know that my original area is 0.7. So if I want my new area, if I want the industrial area, A prime, and this is going to be A prime, and I can't see if I just label that A prime in the industrial zone, I don't have to recalculate anything. I can just take 0.7, which is my old area, times the k factor, in this case squared, k factor squared because I'm looking at area, and that's enough to calculate this. So if I grab my handy calculator, and I take 3 squared, which of course is 9 times 0.7, that is going to be 6.3, and that's going to be my new area. So knowing how the k factor affects area and volume and perimeter actually makes your job a whole lot easier. Now, could you have done this a different way? Sure. You could have used this and found like draw this. You could have used k factor to find this new height, and then done it that way. But this guy's honestly faster if you know the rules. All right, guys. So that's what I have for you for the area and then question 8 kind of combined. I have one more quick video to send out, and that's all I got for you.